All right, hey everyone, we're going to be talking about the periodic table and really the uniqueness of it and how it's constructed. And just to start here, you'll see I have a miniaturized version of the periodic table from this book. And again, you should notice that the periodic table really is aligned with elements along columns and rows. And what's fascinating about it is it actually got developed by Mendeleev, really in the latter half of the 1800s, as he was trying to discover more so the reactivity, or what they used to call the combining power of the elements. As in, what does it take for an element to react with hydrogen or oxygen? And that's how they grouped them together along columns, and you'll see that as you go from the top columns to the lower half of the columns, the mass and the atomic mass of each of those elements increases. But again, many people may get confused that there's similar physical properties of these elements along columns, and that's actually the farthest from the truth. Here's an example of column or group 7 elements, the halogens from chlorine, bromine, and iodine, and we see here that chlorine is just a nice yellowish gas, and we can see that it's filling up the space of this vial here, while bromine is actually a really, really dark red solution. Here is just a highly diluted version of bromine, but you can see it's red in color and it's a liquid. And then finally, one right below bromine is iodine, and it looks at room temperature, it's a solid. So each one of these will react with hydrogen, one single hydrogen, to form hydrogen chloride, hydrogen bromide, and hydrogen iodide, right? But what we see is that even though they react with hydrogen the same, their physical properties are all different. So again, that just shows to the fact that the periodic table was really arranged based on reactivity more so than physical properties and the visual aspects of any elements in the table. One last thing I want you to notice here is that in the group 1 elements, we have highly reactive metals. And these metals react with water to form the hydroxide version. So you'll have sodium metal form sodium hydroxide when it reacts with water, or potassium or lithium. They all aggressively react with water to form that hydroxide version. And just to demonstrate that concept here of like columns have like reactions, we're just going to take one in our sodium metal, and we'll get to demonstrate that firsthand. So I'm going to take the sodium metal here, and I'm just going to gently place it in the water here. And you can see now that it's aggressively reacting, and you can see the fumes coming up. Again, the fumes and the reaction is just actually hydrogen, the diatomic version of hydrogen, H2, actually coming from the reaction. That's a byproduct of this reaction as we're forming sodium hydroxide. So hopefully this demonstrated to you the idea behind how the periodic table got constructed and what is the uniqueness of leveraging the periodic table to do, and figure out chemical reactions across the spectrum of elements. Thank you. So another difference that we're going to actually look at is carbon and silicon. When we look at them in the periodic table, carbon is one row above silicon, but it's along the same column. So we should expect them to have similar, characteristics of reactivity. But again, when we talk about physical properties, they're quite different. And one of those is this table is actually sectioned off in areas where the green of this table are non-metals, whereas the tannish yellow or tannish brownish colors indicate the metals of the periodic table. And finally, we have a very unique set of elements that are considered semiconductors, right, because of their electronic properties. So when we look here now, we see carbon, again, same column as silicon, so reacts similarly when it comes to how it interacts with the protons or electrons. And we see that carbon here is still a dark blackish color, while silicon, the semiconductor, is a shiny-ish blue tinted semiconductor. So again, different physical properties, same combining power, what they used to call it, otherwise we call it reactivity. All right, one of the last things that I'll show you here is just to better understand the physical properties of the metals. And one we're going to talk about is mercury. But before that, just to, again, give you a general idea, we know that most metals that you think about have this silverish color to them. They're typically pretty heavy, like tungsten or iron, or they could be actually fairly light, like aluminum. But again, there are some unique metals out there, like copper with this brownish color. Another one we'll talk about is actually, again, a liquid, is mercury. So what I'll have here is one of my demonstrators just get you to, understand better the unique characteristics of mercury. So if you can come up here, what I'm going to ask you to do is just pick this up. Tell me, how does that feel?
It's heavy.
It's heavy, right? It's heavy. All right, thank you. You can put it down. Appreciate it. Thank you. Yep, that's it. You're good. I appreciate it. So, yeah, just one of the things to note that the density of this material, surprisingly, is very heavy. We think of liquids like water or juice that you drink at home, and they're fairly light to pick up. But this is really takes, good lift to actually generate it. And that just goes to the physical properties of this metal in particular and where it's located on the periodic table, being lower down, higher atomic mass. Thank you.